You all are welcome to Make Boss channel, and you're welcome to this tutorial on partial fraction. So in this tutorial, we're going to be looking at partial fraction and shortcuts. Remember, you don't need to be a scholar to get an A in your course. Okay, now this topic has been broken down into different parts. This is the part 1 of partial fraction. Now, in the part 1, let's look at what we have. Now, it says there are 3 basic types of partial fraction. In the course of this tutorial, we are going to be looking at 3 main types of partial fraction. The first is the one with linear factors, and the second is the repeated linear factors. The third is the quadratic factors. Now, all these are located at the denominator. Is that okay? We are concerned what differentiates or distinguishes a type of partial fraction from the other is what we have in the denominator. So in this case, in the first case, the denominators are what are linear factors. In the second case, the denominators are what are repeated linear factors. And in the third case, the denominators are what are quadratic factors. As you can see in this denominator, we have what linear factors. In this case, it is repeated in such a way that it is what, this x plus a raised to the power of 3. So repeated is in this form, x plus a, x plus, and so on and so forth. Now, how do we represent linear factors? This is how it is resolved to. So you see, this question is resolved to give what? To give this. Is that okay? This partial fraction in the course of this tutorial will always be resolved to give this. Why this will always be resolved to give something like this, and quadratic factors will always be resolved to give something like this. Okay, let's start with the talk or with the English and go on to questions. Now look at this first beautiful question. It says resolve 4x minus 5 over x squared minus x minus 2 into partial fraction. We are trying to resolve this fraction into partial fraction. Okay. Mere looking at this question, you will likely think we use the quadratic factors, right? Because x squared minus 2 minus x minus 2 is seeming like a quadratic the denominator, but we don't use that. The first thing you ask yourself is that, can I factorize that quadratic equation or expression? If you can factorize it to give linear factors, then it is not going to be resolved into, or it is not a quadratic denominator. So we are going to, now let's look at an example. Look at this. We have x squared minus x minus 2. Let's check if we can factorize it. So to factorize x squared minus x minus 2. Okay, I'm sure we all remember factorization. You are looking for a number. Okay, you are looking for factors in which if you multiply them, they will give minus 2. And if you either add or subtract, you give what? Minus 1 here. And that factor will be minus 2 times plus 1. Is that okay? Minus 2 times plus 1 will give us minus 2. And minus 2 plus 1 will give us what? Will give us minus 1. So that's why we have minus 2 here as a factor. We have plus 1 here. If you do not understand what I just did, please go back and study factorization of quadratic expression before you continue. But if you understand, let's continue. So now we resolve this quadratic expression to give what? To give x minus 2 and x plus 1. If you look at x minus 2 and x plus 1, so representing our fraction, instead of 4x minus 5 over x squared minus x minus 2, it gives us what? 4x minus 5 over what? X minus 2 and x plus 1. If we compare to our table, we see that it is resembling the linear factor. So if we are resolving it, we resolve it to give something like this. Is that okay? So this our first question is under linear factors. As you can, okay, let's clean our work. Now, this is an example of linear factors. So we resolve the fractions to give what? So 4x minus 5 over x squared minus x minus 2 will be resolved to give what? A over x minus 2. That's the first factor plus what? B over what? X plus 1, the second factor. Let's continue. Now, how did we get this? It's very, very simple. What we did was that we found what's the LCM of x minus 2 and x plus 1. Of course, the LCM of x minus 2 and x plus 1 is x minus 2 times what? Times x plus 1, right? Now, dividing this with this, x minus 2 cancels x minus 2. What do we have left? We have a into bracket what? X plus 1. We know how to do this. And for b, we will have b into bracket x minus 2. And that's how we got this. Is that okay? Now, we note that the denominators on both sides are the same. Thus, we cancel out the denominators and equate the numerators. What does that mean? It means this x squared minus x minus 2 is the same as x minus 2 x plus 1 because it is the factor of what? Why is it the same? It is the same because if we open this bracket, it will still give us what? X squared minus x minus 2. So since we know that, we just cancel them out. Is that okay? What will remain? Our numerators rather remain. And our numerators are what? 4x minus 5 equals to what? A into bracket what? X plus 1 plus B into bracket what? X minus 2. Up to this extent, I'm sure we understand, right? Okay, let's continue. Now, if you look at this very closely, we see that under A into bracket X plus 1, A is taking to itself a factor, which is what? X plus 1. The remaining factor in which is not with A is what? Is x minus 2. So that factor that is not with A, we equate it to 0. If we equate it to 0, finding the value of our x is equals to 2, right? So now, we put x equals 2 in the above equation to find A. So to find this A, the factor which is not attached to A, you make that factor, or rather you find the value of x in that factor and you put it in the equation to find your A value. Is that okay? Okay, which we've done here. So now put x equals 2. So anywhere we see x, we put 2. So 4x minus 5, we put 2. X here, we put 2. Are you following me? X here, we also put 2. 4 times 2 is 8, so we have 8 minus 5. 2 plus 1 is 3. 3 times A is 3A. Now, 2 minus 2 here is what? Is 0. 0 times B is what? Is 0, right? So 8 minus 5 is 3. 3 times A is 3A. B times 0 is what? 0. 3A divided by 3A, what do we have? A is equals to 1. Do we all understand? That is how to find the value of your A. So how do we find the value of B? We use exactly the same method. So you see in our B, okay, let's go back. In our B rather, we have B into bracket x minus 2. So the factor which is not attached with B is what? Is x plus 1, right? So we equate x plus 1 equals 0, right? Now finding the value of x will be equal to what? Minus 1, right? So since x is equal to minus 1, in this case, for B, we put minus 1 into our equation, right? So instead of 4x minus 5, it will be 4 into minus 1 minus 5. Instead of A into x plus 1, it will be minus 1, and here will be minus 1. Now, minus 1 plus 1 will give us what? 0. Minus 1 minus 2 here will give us what? Minus 3, right? Minus 4 minus 5 will give us minus 9. 8 times 0 is 0, which goes. B times minus 2 will give us minus 3b. If we divide both sides here by minus 3, minus 3 cancels minus 3. Minus 3, minus is what? Plus. 9 divided by 3 is what? 3. So the value for our B is equals to what? Is equals to 3. Do we all understand that? So in this case, we have found the value of our A. We found the value of our A to be 1. We found the value of our A to be equal to 1. And now we found the value of our B to be equal to what? To be equals to 3. So simplifying, or rather resolving our fraction into partial fraction, 4x minus 5 over x squared minus x minus 2 will give us what? We know we resolved it to give A over x minus 2 plus B over x plus 1. So it will be resolved to give the value of A is what? Is 1. So we put 1 here and we put 3 here, and this is our final answer. We have resolved 4x minus 5 over x squared minus x minus 2 to give this. Is that okay? Okay, so let's go on to our next example, which will be our last under this part 1. Now we have, the question says resolve 11 minus 3x into partial fraction. Okay, 11 minus 3x over x squared plus 2x minus 3. Before we continue, let's find out if we can find the factors or if we can factorize this quadratic equation. Okay, we see we can factorize it, right? We've gotten our factors with what? X minus 1 and x plus 3. As I said, if you have problems finding the factors of a quadratic equation, please go back and read or do revision on factorization of quadratic expression. Okay, so we got our factors to be what? X minus 1 and x plus 3. So we can represent this fraction 11 minus 3x over what? 11 minus 3x, let's write it here. So 11 minus 3x over x squared plus 2x minus 3. We can represent it to give us 11 minus 3x over what? X minus 1 and x plus 3. Why is that? Why is it x minus 1, x plus 3? Because they are the factors of what? Of this quadratic equation. Now, we see that this is linear factors, and our linear factors is represented in this way: a over x minus 1 plus b over what? X plus 3. Okay, I'm sure we all get so far. So without wasting much time, we know that if you find the LCM and you do your magic, what do you have? You have a into x plus 3. For those who might not understand what happened there, what happened there was that we found the LCM of x minus 1 and x plus 3, which is what? X minus 1 into bracket what? X plus 3. Okay, using this to divide this, a will give what? A into what? X plus 3 plus b into what? X minus 1. Is that okay? That's how we got this. Now, since these denominators are equal, they cancel out, right? Remaining our numerators, which is what? 11 minus 3x equals what? A into x plus 3 plus b into x plus 1. Let's continue. Now, as I said in the first example, when you have something like this, what is the factor which is now attached with a? In this case, is what? Is x minus 1. So we equate x minus 1 to 0 and x will be equal to 1, right? So we put x equals 1 into our equation. So we have 11 minus 3 into 1 equals a into 1 plus 3 and b into 1 minus 1. 1 minus 1 is what? 0. 1 plus 3 is 4. 11 minus 3 is 8. 4 times a is what? 4a. 0 times b is what? 0, which cancels out, right? So 4a equals to, I'm finding our a. Our a is, if we divide both sides by 4, we divide both sides by 4, 4 cancels 4, a is equals to what? To 2, right? Okay. Finding our b. Okay, before we go on, let's look at what we have for b. For b, we have x minus 1. The factor not attached with b is x plus 3, right? So we equate x plus 3 equals 0. So x will be giving us what? Minus 3. So we put this minus 3 into our equation. I'm putting it, we have it thus. So minus 3 times minus 3 will give us plus 9. Minus 3 plus 3 will give us 0, right? Minus 3 minus 1 will give us minus 4, right? 8 times 0 will give us 0. 11 plus 9 will give us 20. B times minus 4 will give us minus 4b. We divide both sides by minus 4. We divide both sides by minus 4. Minus 4 cancels minus 4. B, 20 divided by 4 is 5. With the minus, we give us what? Excuse me. We give us minus 5. So in this question, we've gotten the value of our a to be equals to, the value of our a to be equals to 2. And the value of our b to be equals to minus 5. So we rewrite our equation to give what? 11 minus 3x over x squared plus 2x minus 3 to give what? Instead of a now, it will be what? It will be 2 over x minus 1. And for b, for b, we have minus 5 here, so it will be minus. Okay, let's rewrite this so that I won't get confused. What we actually mean here is, instead of a over x minus 1, okay, let's write it here clearly. Instead of a over x minus 1 plus b over x plus 3, we got the value for our b to be what? To be minus 5. So it will be plus minus 5. And plus times minus will give us what? Will give us minus. That's why we have 2 over x minus 1 minus what? 5 over x plus 3. So we successfully resolved this fraction to give this partial fraction. So now you see this method is a little bit long, right? Before we come to the end of this class, this method is a little bit long, right? So in our next class, which is the part 2 of partial fraction, we are going to be looking at simple shortcuts that will enable us to solve all these questions in less than 45 seconds. Exactly. All these questions is taking almost 5 minutes. Some people with 10 minutes to solve. We can solve it in 1 minute tops using our shortcut. So make sure you subscribe to this channel. Make sure you like, make sure you comment to get more videos so that you can be able to watch the part 2 of our partial fraction. Thank you for watching. Thank you for listening. See you in our next class.